We're in the Vertex Site Erection Facility now. This is where the Vertex antennas are being assembled, and I'm joined by Lutz Stenvers, the Vertex Technical Lead on site here in Chile. Lutz, can you tell us a little bit about what's going on in here?
We are doing here all the installation, the assembly, and later also the testing. Here on my right side is the antenna number 10, which is right now already fully assembled. You see the carbon fiber bus structure is already lifted on top of the pedestal. All electrical wiring and termination work is already done.
So the entire steel structure is pre-assembled in Texas?
That's correct, yeah.
Right. So these antennas have incredibly demanding specifications. Which was the hardest one to meet when you were designing the antennas?
All ALMA specifications are really, really hard. Now, of course, there are so many special areas. The antenna must be transportable.
Right.
Yeah, we have really made many changes so that the antenna can really driven to the high side, can be changed for the array what you need. Of course, all the pointing specifications are really extreme. Yeah,
and this is pointing in the open air with sunlight on the antennas and in high winds at the high side as well.
I mean, there's a big difference compared to optical telescopes.
Yeah, this really is an immense building. It's very hard to understand the scale unless you're actually here, but as we look up at these 12-meter diameter antennas, each of which weigh over 100 tons, the ceiling of this building is way, way bigger. My guess is you could get a 747 inside this building if the wings weren't on it. It is a cathedral, really.
We are doing right now, and you see my colleagues are working on the platform. We are doing here the servo acceptance test together with NRAO engineers. So we are really able to move and perform all interlock tests, all safety tests, all, as I said, dynamic tests, so that we are fully ready to transport the antenna out of the hall and then ready for the optical pointing test and outside.
Right. So the antennas outside are undergoing pointing, is that right?
Correct. So we have to move every antenna which is assembled here inside and went through all tests. We have to move it to the outside pad, and there we perform the last optical pointing test. One of the key features of this antenna is, of course, the surface.
So each of these little holes on the panels is a hole for an adjuster?
Correct, yeah. So we all these holes, and you see also next to the holes are blank spots where we had photogrammetry targets attached. So we are first setting the dish with a normal satellite, but then we do photogrammetry, and this is another advantage of the hall because we can just switch off the light and do even photogrammetry during day.
And how accurate can you get it?
Our goal is always 60 microns, but most of the time we are delivering now the antennas with around 40 microns.
Okay, and then the final setting is done by holography by the ALMA AIV team?
Yeah, that's correct.
So by my count, there are 13 pedestals and 12 buses down here in Chile, which makes 12 and a half antennas, which is exactly halfway through.
Yeah, so for
does that feel good?
Shipping, we are halfway through. The production in the Northern Hemisphere is already, I think, they are up to 20 already.
Right.
What we have to speed up now is, of course, the testing and
Sure.
the acceptance of the antennas. Yeah. So there we are working now on antenna 6 and 7.
Right.
So.
Well, this is a privilege to be able to hear you explaining this to us personally. This really is the core of what makes ALMA a fantastic project, and its antennas are going to be the thing that makes it a success. So thank you very much indeed.
Yeah, you're welcome, and it's a pleasure. And it's a pleasure also for me to work here.